Before I go on to the other examples I want to do from this section, I want to go back to this one that was no solution. I really should have said no real solution because we are going to have complex solution. So what I did on this graph, just to convince myself that I didn't make any mistakes, I actually I subtracted the 3 over x plus 1 from both sides so that it was equal to 0. So I had the equation equal to 0, and then I actually typed this into y1 for my equation, and then I want to set that equal to 0, so I was looking for the zeros. So I graphed it, and I got this picture, and notice that it doesn't cross the y-axis, so it's never equal to 0. So that kind of confirms graphically that it is there's no real solution, but I should have put that in there instead of no solution. So going on to this next part, this is real simple linear equation, and you guys should all know this quite well, but I'm just going to go over it just to make sure that we haven't forgotten anything. So here, find the equation of the line passing through the given point. So I have two different problems here. So remember what we're going to do. We're going to find the slope, and to find the slope, we're going to subtract the y value. So I'm going to do 5 minus 3, change in y over the change in x, 5 minus 1. So I get 2/4, which is 1/2. Now we had an equation in point slope form, looked like this: y minus y1 equals m times x minus x1. So you're going to want to remember that. I'm going to use that. It doesn't matter which point I use, either the 1, 3 or the 5, 5. I'm going to use the 1, 3. So we have y minus 3 equals 1/2 times x minus 1. This is an equation of the line, but I'm going to go ahead and put it into slope-intercept form. So we get y minus 3 equals 1/2 x minus 1/2 when I distribute that. And I'm going to add 3 to both sides, so I get y equals 1/2 x plus, so when I add 3, I get 2.5. And you can write it as 2.5, but a lot of times we would actually change that to an improper fraction, and instead of 2.5, write it as 5/2. I mean, it's okay if you left it as 2.5, but generally you would see it written in this format. Okay, and on the next one, when I find the slope, I'm going to subtract the y values, change in y, and remember, sometimes you see this, delta y over delta x, to represent the change in y over the change in x. So we have 7 minus 7, and in the denominator, 3 minus 1, so I get 0 over 2. So I have a slope of 0. Now that should just make you realize right away, okay, slope of 0 tells me something, because if I have a slope of 0, my line is looking like this. So I know right away that it's a horizontal line, and a horizontal line is always in the format of y equals something. So to get what that something is, notice that both of the y coordinates are 7, so y equals 7. Now if you plugged it into slope-intercept form and you plugged a 0 in for the slope, the point slope form, you're still going to end up with y equals 7, but try and recognize when there's that little shortcut. Next problem, find the equation of the line perpendicular to this graph, 3y equals x minus 4, and passes through the point -2, 1. So you have to remember what perpendicular means. If two lines are perpendicular, so perpendicular lines have opposite, reciprocal slopes. If it hits a parallel lines have the same slope. So the first thing I have to determine is what is the slope of this line. And I have to do a little bit of work on that first. Actually, all I have to do is divide each side by 3. So I'm going to get y equals 1/3 x minus 4/3. Now, I don't care about this at all. All I care about is this. All I care about from this line right here is what the slope is. So then the slope for the line that I am trying to find the equation for is going to be opposite reciprocal, so it's going to be -3. Okay, so now I know my slope, and I know the point is -2, 1, so I'm going to write it out y minus y1 equals m times x minus x1, and we get y minus 1 equals negative 3 times x minus a negative 2 makes that a plus 2, and then just simplify this. So we get y equals negative 3x. When I add 1, I get a negative 5. Here is the equation of the line that is going to be perpendicular to this given line, and it's going to pass through the point negative 2, 1. Now, the only difference would have been if I had said parallel to this line and passes through that point. Then you would have, from this step right here, you would have had a 1/3 instead, because you would have used the same slope, which means you would have plugged in a 1/3 right here, still using the same point, and of course you would end up with a different equation for that line if it had been parallel instead. Find the equation of the line with a slope of 0 that passes through the point 1, negative 4. Well, I kind of talked about this already. As soon as you see slope of 0, a slope of 0 is a horizontal line. So that means it's going to be y equals something. So then you look here and see what that something is. So our equation is y equals negative 4. Now, if it had been passing through the same point, but you were told that it had an undefined slope is a vertical line. Think about impossible to climb. I know if you had climbing gear and all that kind of stuff, but as impossible, and that might help you remember that that's the line that the slope is undefined. So that's a vertical line, and a vertical line is x equals a constant. So you look up here to see what the x value is, and we have x equals 1. So those problems are actually very easy to do. Next, a little bit of graphing. Graph the pair of lines on the same axes and state whether they are parallel, perpendicular, or neither. So you can actually, now notice this is the x and y was switched around. If you prefer, you can actually graph it. This is in standard form. And if you prefer to graph it that way, you can do that. I'm going to go ahead and change these to slope-intercept form. So for that first one, I'm going to work with that one first. I'm going to take negative 2y equals negative 3x plus 5. So I subtracted the 3x from both sides. Then I'm going to divide by negative 2. So I get y equals, that's going to make this a positive 3/2 x, and it's going to make this a minus 5/2. So that's my first equation. My second one, I'm going to put this over here where I have some more room. So I'm going to add 9x, so I get 6y equals 9x plus 6, and divide by 6. So I get y equals 6/9, which reduces to 3/2, and plus 6 divided by 6, which is 1. So I'm going to go ahead and plot those, and I had said it was okay to go with the convention that if you don't scale your graph, I'm going to assume you're counting by ones, and we're going to count by ones here. My y-intercept is negative 5/2. I'm going to plot that. And the slope is 3/2, so we're going to go up 3, and in the positive direction, 2. And I'm going to do one more, up 3, and over 2. And then you can actually draw your line. I'm going to use my line drawing tool here. Okay. So then for our other one, we're going to plot the y-intercept of 1 and up 3 over 2. And I'm going to go from the point down 3 and to the left 2. I could do that as well. Oh. And we will go ahead and draw that. And put my arrows on there. Should have done that for my red line as well. And we can see that we have parallel lines. Now, I didn't have to graph them to know they were parallel. because notice when I get to this point and I recognize they've got the same slope, but we were asked to graph them, so it was a little bit of practice graphing on this problem, but recognize that if you hadn't been asked to graph them, you could still indicate whether or not they were parallel or perpendicular or neither. On this particular one, you should hopefully notice x equals 4. Whenever you see that, you need to think right away, okay, this is a vertical line, so we have the vertical line x equals 4. I'm going to label this. And my other line, y equals -3, is a horizontal line. So we get y equals, should have used my line tool on this, huh? So we get y equals -3, and we can see we have perpendicular lines. So this is kind of a special case when you have a vertical and a horizontal line, but that should make sense to you that it would be perpendicular. And here's our last problem. Find the slope of the lines that pass through each pair of points and determine whether the lines are parallel or perpendicular. So notice, first of all, it does not say find the equations of the lines. That's good. That makes it easier. It just says find the slope and then use that information. So we're going to do that. So the slope for the first one, I'm going to take 1 minus 3 and 5 minus -1. Now, I just want to remind you, I could have done 3 minus 1 and -1 minus 5, and I'm going to end up with the same value. So I end up with -2, and here I'm going to have 6. So I get -1/3. So now I'm going to try the slope here. I'm going to have 9 minus 3 over 0 minus -2. Be careful when you're subtracting a negative that you don't forget that. So I get 6 over 2, which is 3. So then I can compare my slopes. I see they are opposite reciprocal. So then I know that the lines that passed through these two pairs of points would be perpendicular. So that was a brief review of a lot of information from linear equations, just to make sure that you're kind of up to speed, so you'll be able to do our assignment in class.